Welcome to lesson 14 on data types. In this lesson we'll explore Java's char primitive type. We'll discuss its structure, how we declare and initialize a char type. We'll also look at char special escape sequences and the octal and hexadecimal formats. All of this is possible due to Java using the Unicode character map. We'll also look at the ASCII code. We'll see how to convert from Java's other three primitive types, namely the byte, short, int and long, to char and vice versa. We'll also look at doing arithmetic operations using the char. It's quite a bit of work to go through here, so let's get to it. Java uses Unicode to represent character data. Okay. Now the ASCII code, the American Standard Code for Information Interchange, which is used by some of the languages, is a 8-bit in length. So its range is between 0 and 127, which is a subset of Unicode. So they are still valid in Java because they are a subset. Java is designed for worldwide use. Thus it uses Unicode. As the 8-bit ASCII is not large enough for all the languages in the world. Okay. Now here I'm showing you guys that the last one of the integral of the primitive is the char data, and it's an unsigned 16-bit. These which aren't indicated, as you know, they're all signed. They've got a negative and a positive value. Unsigned means it starts at 0, it's got no negative value. Okay. So it's 16-bit or 2 bytes unsigned integral primitive type. Its range is from 0 to 65,535. A character literal represents char data type. Its wrapper class character wraps a single character in an object of the char type, and it will have various methods and so on that you can use. Okay. It represents a Unicode character, like I mentioned before. Character literals can be expressed in the following formats. It can be a character in a single quotes, as character escape sequences, as Unicode escape sequences, as octal escape sequences. And one can perform arithmetic operations on a char because it's an integral part. Okay. Okay, yeah, I've got a little class and I've named it test char, and I've got a main method, so it will be running from the JVM. Okay, so let's start by declaring a primitive type of type char. So let's go ahead and declare a char, and I'm naming it C. Okay, and now let's assign a value to it. So I'm going to say C equals to A. And now let's print out the result. Okay, so yeah, I declared C as a type, a variable named C type char, and I've assigned, and I'm using single quotes, one of the formats I mentioned earlier on, a C to a value of A, a char value of A, and then I'm printing it out. So let's go and compile it and run it, Java, and I'm going to say test char, the name of my class, .java. So I'm compiling it into memory and running it. And as you can see, there I've got A. Okay, let's declare another character value. So yeah, I'm saying C3, I'm giving it name of C3 of type char, and I'm assigning it a value of J. Let's see what happens. Yeah, this should be C3, sorry. So let's see what happens. I'm going to save the changes, and if I run it, and it's giving me string cannot be converted to a char. Now, remember I told you earlier on, the one way that you can assign a character literal is by single quotes. Now the double quote is not a character literal, it's a string literal. and you cannot assign a string to a char. So we need to change that for it to work. So I'm just going to comment this line out, and let's say I'm going to keep it there for you guys. Char, let's say C4 this time is equal to J, like that. And I'm going to say System.out.println C4, and let's save that one. And yeah, as we saw before, I'm assigning the character literal J, declaring and assigning in one line. There I was declaring and then assigning it later on. Yeah, I'm doing it on one line. So let's see. And there I've got my A and my J. There's my A value and there's my J value, as you can see over here. Okay, let's look at more examples. So I'm just going to copy and paste some here. Okay, and as you can see, yeah, I've got a character literal of 1. So in Unicode, you can also denote the character literals of 0 to 9. Note that this is a character literal and not an integer or int or value 1, 2, 3 and so on. It's a character 1, character 2 and so on, because it's got single quotes. So I'm assigning it to C, which was declared above here. So now C becomes 1, and then I'm declaring a variable named C2 of type char. It's the first time I'm using C2. As you see, I haven't used it before. And I'm assigning it the character / and C4, which I've used before there, I'm assigning it a character of $1. Now, note here that this is a string literal. It's got more than one character. You see, it's in double quotes. And that's a string literal. And so I'm saying C equals a string plus the character. So it's going to print that value 1 there. Then C2 is going to print that character's value. And note I'm going to the next line. So if I want to escape to the next line in my print line, I can just say plus there, which is concatenate actually. And then it will just as if it was on one line. Okay, so I'm going to save this. And I'm going to run it. Java. Okay, I'm going to run it. Java test char.java. And as you can see, there's my value C1. C is now equal to 1. C is equal to 1. And C2 is equal to that character. And C4 is equal to my $sign. What do you guys think the result will be? What will be outputted here if I assign XYZ character literal to C? So let's try and compile that and run it in memory. And I'm getting a compiler error, unclosed character literal, and that's because a character literal is only one character. Okay, so you'll get a compile error if you try and have 2, 3 or 4 or more characters. A character literal is composed of one character. Okay, so I'll comment that code out because we know it gives a compile error. So what about this code? What do you think will happen here? I'm assigning a backward slash to a variable named C2, which is of type char. And then I'm outputting it here in a print line statement. C2 equals to backward slash, which is this line over here. I'm putting it in a string and I'm saying to output its value as well. So let's see, I'm going to save it quickly. And then I'm going to run it. And for some reason, it's complaining, even though we just got one character. Recall on the previous compile error there, we said a character literal can only have one character. But yeah, it's one character and it's giving an error. Why do you guys think that's happening? Okay, I'll comment that lines out so it won't give me a compiler error. And now we come to the next part. Remember that until here now we've been using a single quote for a character with a character in between, which like these over here and over there and so on. And this one is giving an error. Okay, the second part is a character literal can also be expressed as a character escape sequence. And an escape sequence starts with a backslash. That's why it's giving an error. Now Java's got 8 predefined character sequences. Backslash N for line feed, backslash R for carriage return, backslash F for form feed, backslash T for tab, backslash B for backspace, backslash, note, backslash for a backslash, and a backslash semicolon, a double quote, for a double quote, and a backslash single quote, a backslash and a single quote for a single quote. Yeah, I'm assigning a single quote, backslash single quote to the name single quote, character name single quote, a double quote to a character type, a char type, let me say, with double quote. I'm assigning a backslash to a char named backslash, a tab to a char named tab, and so on, a backspace, line feed, form feed, and carriage return. And I'm going to use them. So I'm starting, and note I'm using the System.out.println, so it doesn't print a line after it's outputted. It's not the print line that I've been using over here. It's just a print without the ln, meaning it will print and it will stop there, the pointer of your cursor, and the next dot will carry on the same line, and on the same line it will encounters a print line or a line feed. Okay, I'm starting as usual with an empty string so that it won't convert to ints. So what I'm doing here is a single quote, which is this one here. I could have written it out like that as well there. And then the character A and a single quote. So it should give me a single quote, a single quote. And then on the same line, I'm tabbing over. And then a double quote, B double quote. So then the next line should look like that. And then a line feed. So when it comes to this one, it's I'm using the line feed, so it should print the next line, then a tab, then a backslash C backslash. So as you can see here, when it comes to B, when it comes to this one, it should go to the next line because there's a line feed. It's the same as the print line. If I had a print line there, then it should go a tab, should tab over to the next, and then it should display this. So that should be more or less my display. So let's see. I'm going to save it. Let's see what happens. I'm just going to clear this. Then I'm going to say Java test char.java, and as you can see, we're looking at this output that starts with an A in a single quote. There's an A, that will be the first line, and just to show you what I mean that it is the first line, I'm going to comment this one and this one first, and also this last line here. I'm going to comment those out. So let's try again like that. And you can see there's just my A. Okay. And then it stops there, and everything else is on the same line because it wasn't a print line. It didn't print A and then a next line. Okay, now if I take the comments out of this one and I save it, and let's compile and run this one. And you can see now on the next line, on the same line, because it's a print, it's not a print line, so there was an A, and now it tabbed over, and it printed a double quote and then the B and a double quote on the same line still, and it's still a print, so it didn't print another line after the output. So let's just uncomment the next one. I'm going to save that. Let's try it now again. And yeah, suddenly we got a new line. Now why is that? Because you'll see on my print here, it's got a line feed, and line feed character, this character here, \n is a line feed. It's the same as if you had a print line over there. So what happens is it first line feeds, and then this is a tab, same as there, but yeah, I used the escape sequence literal, and then yeah, I'm also using escape, so it tabbed over, and then I'm outputting a backslash there. For a backslash we need 2 because the first one is the escape sequence, and then the character C, and then another backslash. So here's that line, it found the new line, the line feed, tab, and then the backslash C backslash. Okay, so I've got a last one here, so let's uncomment that one and save it, take the comments out, and let's see what happens. And the last one, if you look at it here, once it comes here, it says print line, but that will be at the end when it prints the line. As you can see, it's this gap over there, sorry, this gap over there, after that gap underneath it. Okay, so what's happening here is now we got, if you notice the previous one, it had, what I'm doing here is I'm going backwards now, I'm backspacing one. So where there, if you recall the C, here it is, add a backslash C backslash, now my cursor is there, and now when it encounters the backslash here, it moves one back, and so that it's over where that last backslash was, and then I'm printing a single quote. As you can see over here, that's a single quote. There's my single quote instead of the backslash D, and then another single quote, and then at the end here I'm saying a new line, and I'm printing a print line. So now I'm giving you two, a new line plus another new line here. Now the character A has a capital A has an int value of 65, and the small a, the small character A, has an int value of 97 on the Unibase character map. Okay, so as a character, and note that as a character is unsigned, as we learned before, when we assign a character to an int, a short, and so on, it must be cast. You must cast it. Okay, so let me give you examples of what I mean. I'm going to just copy and paste some code here. Okay, so yeah, I'm assigning the character literal capital A to an int called I1, and note us what happens. Yeah, let's see what happens. Okay, so in down the byte, I'm assigning it an int value of 66. Yeah, in a short S1, I'm assigning it a character literal a small a to a short, and yeah, C1, C2, and C4, which are all characters of type characters. If you recall, if you go up, you'll see the C is a character, C2 is a character, and so on. We used in them before, so I'm just reassigning them, but I'm casting it. Okay, because I stated here that as a char type although it's an int, it's assigned, it's not unsigned, so you have to cast the int because the int could be a negative value. Okay, we'll test it now, and then yeah, I'm going to print out I1, which is an int. So yeah, I'm going to print the int, the byte and the short, and then yeah, I'm going to do the same, but I'm going to print the character C, character C2 and character C4, which are these here, which I've assigned the int, the byte and a short to it. And then yeah, I'm printing out the capital character A, B and small character A. And then next over here I'm going to add a string literal in front of those, which I'm doing the same there, but I'm using a string literal there. But over here I'm going to print two characters first, then a string literal, then a character literal, and then an int. So let's see what happens with the output of these. I'm going to run it, java test char.java, like I've done before. Okay, so let's compare this to that. That is that there. Okay, so as you can see, the first value is 66. I1 is A, and I1A, I've said before, capital A has an int value of 65. So 65 plus B, which is 66, plus the small a, which I've assigned to short, which is an int value of 97, gives me 228. Now in the next one, I'm just using the char values, which I've assigned to them again, and it's giving me the same value. Okay, so that proves that the I to a character is still got an int value of 65, C2 66, and C4 97, which is the small a. And yeah, I'm just showing you again with character literals, and I'm still getting the value of 228, which is that output there, the first three there, as you can see. Okay, the next one, I'm just going to bring it down like that. I'm starting it with a string literal. Now what happens when you start with a string literal? Then it converts the int values to its character equivalent. Okay, because it started with a string literal here. So I1 here, which was a value of 65, it's actually going to give me the int value 65, which you can see there because it's I1 is an int. I1 is an int. As you can see, I1 is an int here, which has got the value of a character literal A, capital A, which is an int value of 65, but now it's printing out that character value of the int instead of adding them together. It's concatenating them, as you can see. So it's printing out 65, 66, 97 because I started it with a string literal. It's not adding them all together and giving me one value. So when you start with an empty string, then you're telling the print line to print it out as its character value on the Unicode, instead of treating them all as summing them up over there. Okay, the same thing with this one. I'm just using the character instead of the int and the byte and the short. I'm using character plus character plus character, and as you can see what's happening there, it's giving me the character value instead of the int literal. Is giving me the character A, B and small a, which I said there that we've assigned them, as you can see over there. Okay, and then the last one, what I'm doing is I'm actually only putting the string literal inside, so these two characters are actually going to be treated, it's going to use the int values and it's going to add the two together. So it's going to add the 65 with the 66, which is going to give me 131, and then it's going to print the Z. But because it's now on the string literal, the Z and the 25 don't get added anymore, because now that what it's going to output here, it's Unicode character equivalent. So it's going to print the Z and 25, the character literal 25. So as you can see there, it's going to print out 131 Z25. Okay, next we're going to look at a character literal expressed as a Unicode escape sequence. Okay, to have a Unicode escape sequence, we start with escape character and then the U. That indicates a Unicode escape sequence. And then we use a 4-digit hex number. And as we know, the hexadecimal 41 is the same as a decimal value 65, which represents a character capital A. Okay, and we know that the range of a char is from 0 to 65,535, and that range in hex is from, we'll denote as a Unicode escape sequence with 4 zeros and a Unicode escape sequence with followed by double F, 4 Fs for 0 to double F. Okay, so what I'm doing here is, in the first one, I'm assigning C4, variable C5, of type char, the character literal capital A, and then, as we know, the Unicode escape sequence 0041 is the same as the capital A, which is 65. Okay, then what I'm doing is I'm going to print out char C5 equals to A, and it's going to print that out because it's in a string. Then I'm going to tab over, this is a escape sequence, a tab, a special escape sequence. Then again a string value is another tab, and the value of C5, which is an A. Then in the next line, see, I'm using a print there, and then it's finding a line feed escape sequence. It's going to go to the next line, the cursor, and it's going to print char C6, and C over here, because I wanted to have that /U, then a semicolon at the end, I'm using that over there. Okay, and then a tab again, value, a tab, the value of C6, and then a new line again. Okay, so let's just see what that part does. So I'm going to save it, and then I'm going to run it, and as you see there, I'm saying here char C5, that there, char C5 is that over there, is A, tab value is A, and then char C6 value is, and you can see I'm printing out because I'm using that escape sequence there, so it's giving me that over there, plus then that and that one over there, the single quotes, value is A. Okay, let's look at the next part of this, what I'm assigning, because the escape, the range in Unicode is 0000 to 4 Fs. I'm now reassigning the char of C5, the initial value of 0000 in Unicode escape sequence, and then I'm going to print it out, and the max value in Unicode escape sequence, and we've already run it, so I can just show you. So 0, 0 is an empty field, and the maximum one gives me a special field, looks like 4 F's over there. Okay, next we're going to look at getting the range of it with using the wrapper class called character, and it's spelled like that, found in the java.lang package. So what I'm doing here, I'm going to print out char min value is, and then I'm getting the character min value, and notice I'm casting it to an int. Okay, and then the next one, char max value, and I'm going to get character.max value, and I'm casting it to an int because I'm getting a character that a character max value and min value there returns a character, and I want its int value. And then I'm doing the same here, but what I'm doing is I'm using the integer 2 hex value, and I'm getting the character's min value and max value, and I'm going to print out its hex value. Okay, so let's go ahead and do that. Let me just save it quickly, because I don't think I did, and now let's run it. And as you can see, the char's min value is Z in the int format. The char's max value is 65,535, and in hex value it's 0. Note it only prints a 1 0 when it's no more other values, and then double F it's its max value. Now the character literal can also be expressed in an octal format, and it will have a format as over there, a single quote, backward slash, escape sequence, and then 3 digits. Now its range is between 0 and 255 because you see it's 3 bits, or in octal format the range is the escape sequence, the backward slash, in other words 0 0 0 in single quotes to in single quotes backward slash 377. It's a subset of all the characters in the range of the Unicode range, which is 0 to 65,535. The octal format exists for comparability with other languages that represent the characters in 8 bits. Java makes use of the Unicode to allow for all languages in the world, where the Unicode format must be, and note, it must be a 4 numeric value. In other words, in single quotes, backward slash starts with a U, and then it must have 4 digits. In that case there is 0041, which represents a capital A. In octal format, one can make use of 1, 2 or 3 numbers, and note the difference between the two there, where I can denote in single quotes backslash a 1 or 01 or a 001, obviously a maximum of 3 digits since it's a 7-bit. Now if we look at the ASCII table, we're just going to look at that quickly. You can see the decimal, which is the int values, and the hexadecimal equivalent, and then the octal equivalent, and what the character it represents. Okay, so if we look here at the capital A, which over there, you'll see in the decimal format, which is represented by the int in Java, it's 65. The hexadecimal will be the value of 41, and the octal 101. Obviously in Java that will have in quotes, in single quotes, and then a backslash U0041, or in octal in single quotes backslash 101, and they will all represent the A. Going back to our notes. Okay, so that is what I was showing there. The capital A in decimal is 65, in octal 101, and hexadecimal 41, but we need to represent the octal literals, and here's the octal literals there, and the hexadecimal literals, example of it over there. Okay, so let's test this. Yeah, I've got a local variable with a name A in capital letters. It's of type char, and I'm assigning an int value of 65. Then here I'm reassigning the Unicode literal to A, the Unicode 41, and there I'm assigning the octal value of 101, and if you recall, they're all A, so I'm assigning, and eventually they will all assign A. Obviously the last one will count there. Then yeah, I've got a character next line, and I'm using the octal 12, which is the same as the line feed. And if we go and look at that, we can look quickly at the character 12, and you'll see the octal character 12, which is this one here. It's a new line, or a line feed, which is the same as the hexadecimal A, or the decimal integer 10. Let's go back to our notes and our program, and then yeah, I've got a local variable called bell. It's of type char, and I'm assigning it the octal literal of 7. And yeah, I've got a char local with a local variable called space of type char, and its Unicode literal is 40. And then I'm going to print here, go to the next line, and then it's going to go to the next line, which is that one there, the next line variable, that one there. And then now ring the bell, and that's the bell there, which is a octal literal of 7. And then print A, and that it will be A, which will be the octal literal 101. And then it will have a space, and then I've got here octal literal of 102, and if we go look at 102, we go back there, and 102, octal 102, let's go look. Octal 102 should then be a B. So let's just go and save, make sure we've saved that. Let's go and run it. Java test char, I think is what I called it. And I've got a problem. My A, the Unicode value is giving me a problem here. And you recall that I said here that the Unicode must be of 4 numeric values, and yeah, I'm only using 2, where the octal could be 1, 2, or 3, and you can see I'm using 3 here in this octal. I'm using 1 over here and 2 over there and over there for octal, but the Unicode has to be 4, so I just put 2 zeros in there. Save it again. Let's try again, and if everything works well, and you heard the ping, that was the bell. So if you guys didn't hear it, just listen. I'm going to run it again. There's it. And as you can see, go to the next line, go to the next line, the next line, which was octal 12, it went the next line, the cursor in other words. And then now ring the bell, and that's when you heard the ping, the bell, which is the octal value of 7, and then print A, and there's the A and the value of A, that octal there, which is the last one I signed. Well, all of them would have signed, but obviously the last one is the most recent one. Octal value 101. Then a space, and you recall the space is, yeah, this octal literal /40, and then the 102 we want to look is a B, and there is the B. Okay, we can put another line of code here. What do you guys think will be the output of this one? I've assigned a local variable named wrong char of type char, the octal value of 378. So let's look, what will the value be? So I'm going to run it, and as you can see, I'm getting a compiler error. And why am I getting a compiler error? If you recall, over here I said that the octal range is from 000 to 377, and that's 378. Okay, let's look at another example of assigning a value using the different formats. I'm assigning a char value using an int or an octal or Unicode. So now the character A, capital A in Unicode, uses the hexadecimal numbering system as we saw previously, U0041. Its int equivalent is 65, and in the octal format it's 101. Obviously they're using the escape sequence like there and over there. So yeah, I'm just going to print it out to the console. As you know, I'm using an empty string in the beginning. Then there is my Unicode literal. And then I've got a space here, a string with an empty string, space. And then note here, int 65, I'm casting this one here, I'm casting to an int. If you can see there, I'm casting to an int. And then I've got the Unicode literal of 101. So let's go, and I'm going to save it, and let's go and run that. And as you can see, there's the A space A space A, A space A space A. What would happen if I remove this casting here? You guys know. So if I remove this casting of a char here and I just say 65, will it print the same? Will it print 65? What will happen here? Okay, so let's have a look at that. So I'm going to save it like that, and I'm going to run it, and as you can see, it now prints the character 65, because I've started it with a string there before, but it doesn't map it to the Unicode or the character map. In other words, from an int to a character, it takes the int value 6 and 5. So let's just put the char back there. Char back there like that, and save it, and it's back like it was, and there it is. Let's look now at the values such a byte, short, and int when we want to assign them to a char. Now, if you recall, your byte, your short, your int, and long are signed values, meaning you got negative and positive numbers, where your char is unsigned. For that reason, when you're going to assign any one of those to a char, you must cast it. So yeah, I'm assigning a negative value 65 to a local variable b2 of type byte, and then I'm then assigning that local variable b2 to a char c, but I have to cast it first, and then I'm printing it out, and that c is a char because we declared it right at the beginning. If we go look right at the beginning, there it is, c is of type char. Okay, so let's try that and see what happens. it's going to be java this char.java, and the last thing is printed. See, the negative 65 gives me some funny FFBF character in my character map. It's mapping to something like that. Okay, now if, let's say I uncomment that one. Now what's happening here, and I'm going to comment this one out. Now I'm taking the B2, which is minus 65. I'm not casting it first before I'm assigning it to C, which is of type character. So let's see what it does then. And you see it's giving me compile error, possible loss of conversion, byte to a char. Okay, I've commented the one that's giving me a compile error out again, and I've uncommented the one that was fine. Now I'm going to add some more code here. Now what about the other way around, from a char to a byte? If you recall, a char is 16 bits in Java. So it's important to remember at least the size of the bits. It will help you. And the byte is only 8 bits. So 16-bit can't fit into 8-bit. So you'd have to cast it. So yeah, I'm assigning a character capital A to the local variable C, which is a char. And then over here, I'm taking that local variable C, and I'm casting it before I assign it to a byte. As you can see there, B2 is a byte. And then I'm printing it out. Let's see what happens. And as you can see, I'm getting 65. And because I'm casting it back to a byte, and recall a byte is of the int. And if you go and look at the character map again, you'll see that capital A, its int value, a byte is an int value, is an int, is the smaller form there of an integer or integral, let me say 65. And that's exactly what I'm getting there. So I've got to cast character back to a char. I've got to cast a char to a byte before it will fit in the byte, and then it, in this case, it outputs 65. Okay, let's look now at the short and the char. So the first one that I've got here, let's look at from a short to a char. Yeah, I'm assigning the int value of 97 to a local variable of type short. Then I'm assigning that type short to C, which is a char value. As you recall, right at the top here, we said C is a char. So then we're going to print it out. Let's see what you think is going to happen here. Let's run it quickly. And as you can see, I'm getting a compile error, incompatible types, possible loss of conversion. And that is, as you know, the short, although it's only, it would fit into a char, but it could be a negative. So we have to cast it. So let me put a cast in there. I'm going to cast it, save it. And let's try now. And as you can see, it's the last one here. It prints a small a. So the int value 97 gives me, if I cast it to a char, gives me a small a. And we can go look at our map, our Unicode map. an int of 97. Here's your decimals. There's 97. This one's there. You see over here, 97. The corresponding hexadecimal would be 61, and the octal would be 141, and its Unicode representation is an A. It stands for A. Okay, let's look now the inverse from the char to the short. So yeah, I've got the char, the reference or the variable, local variable C. I'm assigning it to S2, and we know S2 is a short, and we know C is a char, so I'm assigning a char to a short. And what do you think will happen here? I'm just going to save it. Let's run it. And I'm getting the same problem. And why would that be happening? And that gives me a compile error, because even though both of them are 16 bits, if you recall, the short is from a negative to a positive, a negative 32,768 to a positive 32,767, where the char is unassigned, meaning it's only positive numbers, 0 to 65,535. So you have to cast it, and because there can be a possible loss of precision and so on. So I'm going to cast it here. I'm going to cast it to a short, as it must be, because we're assigning it to a short. Save it again. And I'm going to run it. And now you see it's 97. The inverse has happened now, because as you recall, and I'll just show you again, yeah, we're going in the other direction. We're saying the character is an A, and we want the short, which is decimal, is an int value, and that is 97. Now we're going to look at the int and the char this time. So starting with the char to an int, yeah, I'm assigning the local variable called C, which is a char, to I1, which is an int, and I'm outputting it. And it is fine. We can do that because the char value is 16 bits, and as we know, the int is a 32 bit, so the char will fit in an int. So let's save it and run it. And as you can see, the result is 97, as I stated over there. Okay, and then now from the int to a char, as you can see, I've commented that one out because it will give us a compile error if I go from int, from I1, there should be a 1 there, I1 to C will give me a compile error. Let's just verify that. I'm going to save it, run it. You can see it's incompatible type, possible loss, because int may be negative. Recall that the char, as you guys know by now, it's unsigned and the int is signed. So we must cast it. So I'm just going to comment that one out. The next one there, as you can see, I've cast it. And then in the next line, yeah, I've also commented this one out, because if you recall, the char value is it's got a range of 65,000 and 65,000 and so, if you recall, and this one is 75,000. So if I uncomment that one, I should get an output here, and then a compile error there. So let's just save it and run that. And as you can see, I'm getting a compile error there, 75,000. Okay, so because it's larger than the range of its int values for a char value, which is just over 65,600 and There's a 65,535 is the exact number. Then now I'm casting it, and because I'm casting it, the original value will be lost. Then I'm reassigning, just to show you that 75,000, I'm casting it to C, which is a char. And then I'm taking that char and I'm assigning it back to I1, the int. So there the int, the int value was 75,000. What will it be now? I'm going to print out the actual C, the char value, and then I1, which is the value that I've been assigned back to I, if you get it that way. So let's see what happens. And as you can see on the last line here, my char value is this funny 4, and my I1, which should be 75,000, is now 9,464. So there was a loss of precision there, as you can see. Okay, by now you guys should be getting an idea of how it works. So I'm just going to paste the code here and quickly go through the long to char. And as you can see, I'm initializing the char with a capital B. And then I'm assigning the char value to a long, and that's fine because we know a char is assigned 16-bit and we know a long is an unsigned 64-bit. So it will fit, and then we're going to print it out there. And then the same as the int, you can't go from a long to a char. Apart from it being too big here, it's also got a negative number. So you've got to cast it, and then we're casting the long back to the char, and we're going to output the char value again. So here we should get a value of 66 because we're going from B from the B value to its int value, and then we're going from the int value back to the char value. So let's just save that and let's run it. And as you can see, the last two outputs, that one there is 66 and that one there is B. Apart from that, we're going to end this lesson with we can perform arithmetic operations on a char, and that's because, if you recall, a char is a part of the integral primitive types. The others is the byte, the short, the int, the long, and we're looking at the char now. So I'm just going to paste some code here. Okay, so I've pasted some code here, and I'm just going to go through it quickly. I'm assigning a local variable called ch, a value of a char literal, yeah, there, as you can see. And then I'm going to print out the value, and then yeah, I'm adding 2 to this value, and then I'm printing it out again, and then yeah, I'm using the decrement, so I'm minusing it by 1, and then I'm printing it out again. Just show you we can do mathematical operations. We will later on look more at operations and so on. So let's go and see. And you see they are printed out. If you look at that, there I've assigned x to a char. I've printed out char is x. And then I've added 2, so it's x, y, z. If you add 2 to it, char is z. And there I minus it by 1, which is a decrement that, and then it is y. Now we've come to the end of this lesson on Java's char primitive type. We saw that Java uses Unicode that defines the character set found in all human languages. The char is a 16-bit unsigned integral primitive type in Java. We also saw that the ASCII is a subset of Unicode. Lastly, we can do arithmetic operations using the char and even ring the bell. I hope you enjoyed this lesson, learned something from it, and please don't forget to press the subscribe and notify button. I've also got a Facebook page related to this channel. Until we meet again in our next lesson, I wish you well and happy coding.